Hi, this is Mr. Messerman with the fourth quarter Flipped Classroom Vodcast. Music of Waters number 7. I can determine specific and relative humidity and relate them to temperature. So I guess the real question to ask is, why are there clouds up there but not down here? Okay, first let's think about condensation. You can see water condensing at the top of this boiling pot of water. Why is that happening? Well, air can only hold so much water, and when you boil water, you force a lot of vapor into the air. And the air cannot hold all that vapor, so right above the pot, the water condenses and we see the steam. Now keep in mind that steam is condensed water. It's water that has gone from a gas to a liquid. And if you remember, clouds are made of liquid water or ice crystals. We can see them. We can see steam. We can see clouds. It has to be little tiny droplets of water, liquid or solid water. So we're trying to force too much water into the air and it just can't hold it. Okay, now let's think of this from another perspective. We're going to use a glass of ice and water, and we're going to fill the glass with ice and water. Get it very, very cold. Now, when you watch carefully this glass of water, I sped up the video here. Watch the glass, watch reflections in the glass, and you'll see them fog over. Now, what's going on here? Instead of forcing lots of water into the air with heat, we are changing the air's ability to hold water by making it very cold. The air right next to this glass gets very, very cold, and the capacity of the air to hold the water goes way, way down. So just what is this term capacity? Well, capacity is defined as the quantity of water that air can hold at a given temperature. So what's happening here with this boiling pot of water is that we're forcing more water into the air than the air can actually hold. So right above the water here, the air becomes what we call saturated with water, and it can't hold anymore. So some of it ends up as steam. When the air can't hold the water that's there, it will form little droplets. It will condense and make a cloud or make steam. Okay, let's think about this term saturated a little bit more. Air is a lot like a sponge. So here I am allowing the water to run on a sponge. Now notice that the sponge takes the water in. Okay, and eventually the sponge becomes saturated and water begins to run out. So the sponge has reached its capacity to hold water. It is fully saturated and it has no more room for water. Now when we wring out the sponge, it's just like cooling the air around the glass, and the water in the air was wringed out by cooling the air. When you squeeze a sponge, you reduce its capacity to hold water. And so the water has to come out. You can do that to air. Just cool it off. Okay, here's an overview of the main terms. Capacity is the quantity of water the air can hold at a given temperature. It's expressed in grams per kilograms, which is grams water per kilograms of air, or millibars, the pressure of only the water vapor in the air. So what holds more water, warm air or cold? Saturation, when the amount of water in the air equals the amount it can hold. Saturated air usually forms steam or clouds. Specific humidity, the amount of water in the air right now. Relative humidity, the amount of water in the air compared with the amount it can hold. So that's the specific humidity divided by the capacity. All right, let's pretend that the temperature of the air is 10 degrees Celsius. Reading the capacity chart, that gives us a capacity of 7.8 grams per kilogram. Now, what if the dew point equals 0 degrees Celsius? That means there is 3.8 grams of water in a kilogram of air. To find the relative humidity, divide 3.8 grams per kilogram by 7.8 grams per kilogram, and that equals 0.49 or 49% relative humidity. Now, to try to answer the original question, why are there clouds up there and not down on the ground? Well, if there's clouds, that means that the humidity is 100% up there. Why? Well, in this picture, I think the trees might be contributing some moisture, maybe after a rainfall. But it's at a higher elevation, a higher altitude, where the air is cooler and the capacity is lower. Thanks for watching.